Hello, let's look at how to do an organic mixture separation in the laboratory. So in this video, I'll give you a flowchart and some terminology explanation and some apparatus, how to use it. So the mixtures are acids and neutrals or bases and neutral compounds. So A and B, N for neutral, A for acid, B for base, right? So let's look at two types. So we also need to know some terminology and some equipment. So the pH test, we're going to be talking about that. So you can also remember red for acid, litmus turns to red when it is acid, and litmus turns to blue when it is basic or base, right? Okay, so what do we need these ones to be done? Because we need to use litmus to know if we done an acidification or basification correctly. So acidify means you add acid into your mixture. So that's normally HCl 5 molar, 6 molar, similar to that type of concentration. And basify means added sodium hydroxide, again about 5 molar or 10 molar, what is given solutions for you as reagents. Now, we can also look at in the mixture separation that, like I said, acid and neutral. So that's a type A and N is a type A. And you need a different flowchart for it. If you have a base and a neutral, so that would be a different flowchart, right? So the procedures are a little bit different. Now, so let's look at the apparatus. So this glassware, which is a separatory funnel, and this is used to separate to do the solvent extraction. So separatory funnel, I call the SEP funnel, right? So this one has a stopper to put it on the top. That's a stopper, usually a plastic one. And then you have a stopcock, which is Teflon, and usually it's a Teflon one. It's easy to handle, to open and drain what is in there, the liquid. And here you have a glass stopper. But so what's the other thing? So in this, so it's written on a ring stand, right? So 3 times 15 milliliter extraction means, so you're going to do 3 times each time you have a 15 milliliter. So what do? You add 15 milliliter into your mixture and add it into the SEP funnel and vent it first, and then shake it as shown, right? Now vent it, shake it, vent it, shake it, and then you put it on the ring stand, open the stopper and settle and separate by the stopcock opening, and take it into the beaker or the Allen-Meyer flask. So normally aqueous and DCM would be in the bottom layer because it's denser, right? Now the use of gravity filtration, and so the filtration is used to separate the drying agent, sodium sulfate mostly, or any other solid particles to separate. So what do we use? We use a fluted filter paper. Now, if you have your beaker with organic solvent and your, let's say your organic acid is in it, and you add some sodium sulfate drying agent, and that would make clumps, and you add more, it'll make it look like sandy. Now you filter this one, so your solid sodium sulfate hydrated form will stay in the fluted filter paper, and your purified solvent and your HA will be in the flask or the round bottom flask. Now we need to do the evaporation. So that we are going to use a rotovap. So this looks like normal rotovap, right? They could be slightly different from one to the other. But what's the important thing? So the solvent evaporation done by this one, this is the flask that you have your organic solvent and your mixture A or B, right? And it's after filtration, no solid particles in it. So now you open the vent first and make sure you have a waste collector in place, and then the condenser is here, and there should be a water running from the behind. It cannot be seen here. Now you have a heater bath. You hook up things and start spinning the rotovap, and then start heating. So then you can remove your solvent to the receiver flask, right? Once you have it, that's a crude product. You might be doing a crystallization or distillation to purify that. Once you have it, you're going to check if it is a solid, melting point, if it is a liquid, boiling point, or refractor index. So checking the melting points, you add the solid to the capillary, 1 or 2, and put it there. Look through the lens here, and you take the reading when they start melting and end melting. The midpoint is actual your melting point, right? You can get an average. You check with the data sheets or CRC book. Voila, you have what you need. Now, if it is a liquid, you can do a distillation. So in the distillation, you add, let's say you have two solvents, methanol and ethanol. You put it to the flask, and you have a thermometer here to measure the temperature, the boiling point, and the condenser, water added from the bottom and then taken out from the top, right? Sometimes you have a column. You definitely have a receiver flask. And in cases, we can also use a vacuum system if it is given. So this one is not a vacuum one. So the vacuum distillation also similar, right? So that's the distillation. If you done the distillation, you know the boiling point, then you can look at the data sheets. Now let's look at mixture separation, two flowcharts, one for the acid and neutral, the other one for the base and neutral. Yes, so it's a good idea if we have like flowcharts like this one. So you can have actually two, one blank, one written what you will be doing, right? Especially for when you're going for an exam, it's better to have two charts. Okay, so let's say my unknown is HA, the organic acid, and N, the neutral compound. It is toluene in this case, and benzoic acid. Now this mixture should be separated using the methodology that we were talking about, the techniques that previously we talked about, right? Let's say this you dissolve in 50 milliliter of DCM or ether, whatever it is given. Okay, so DCM normally in the SEP funnel will be going into the bottom because it's denser, and ether will be staying on the top because it's less dense than water. So that's something important to understand and memorize depending on what you're using. Now here we're going to do the extraction 3 times of 15 milliliter sodium hydroxide extraction with dilute sodium hydroxide and separate the aqueous to organic. Now focus on the organic layer, so the neutral compound and with water there, right? So there could be still some sodium salts. We're going to get rid of that one by washing with sodium chloride. So look at the aqueous side, you have acid salt, in this case sodium benzoate, or you can think A minus and Na plus. So it's ionic, that's why it's staying in the aqueous layer. So you have water there. So if we continue with the aqueous layer, so initially you need to have cool conditions and then acidify and pH check, and with the concentrated HCl you acidify and then check the blue litmus turn to red. So then you have done the acidification right. Okay, now so but your compound turned to organic acid, but you need to extract with 3 times 15 milliliter DCM, let's say. Now so you separate again with the SEP funnel organic and aqueous. Keep the aqueous, don't throw it. And the organic layer, you can do the drying with sodium sulfate, filtration with the gravity filtration, and then evaporation at the rotovap. Now you have the acid crude, HA crude. You can do the purification if it is a solid recrystallization, or just you can do the melting point analysis for the crude. So if you have it, then you check the aqueous and discard the aqueous as you are advised, because it's contaminated water, right? Okay, these two boxes we don't need. We look at the organic layer then with the neutral. So we are not actually not drying right away because we need to wash with sodium chloride, sometimes you call brine. And then you can do this washing with 2 times of 15 milliliter of concentrated sodium chloride, get rid of the ions, and then you have aqueous and organic fraction, right? By the SEP funnel, you can just separate. It's not 3 times now, right? So you take the organic layer, the traces of water will be removed by drying agent, filtration, gravity, and then evaporation at the rotovap. You get the crude neutral compound. If you have it, discard the aqueous. And you can check the melting and boiling points depending on the solid or liquid for the normal neutral crude, or you can purify that too. So that's the acid and neutral compound separation. Sometimes your professor don't have to tell you it's an acid, it's an unknown. So you can do a litmus test at the beginning and then decide whether it's an acid and a neutral. Okay, so we can do another one with the base and a neutral. So let's say you're told, then it's easier, right? If you're not told with what it is, then you have to do the initially litmus test to figure out whether it's an acid or a base existing. Okay, so again, so let's get started here. A blank flowchart, right? So it's easier. So let's say in this case you have neutral and the base. So the base would be something like chloroaniline, something like that, and then you add into 50 milliliter DCM or ether. One of them is enough. So 3 times of 15 milliliter extraction with HCl diluted. This one because you want to make the salts of the base, right? And the neutral compound goes into the organic layer, and that's the neutral organic compound, right? So what do we do for the organic layer neutral? Wash with sodium chloride 2 times 15 milliliter extraction and separate the aqueous, keep the aqueous. And the organic layer, you have nitrogen neutral compound and you have water traces. So that one you're going to be drying with sodium sulfate, filtration with the gravity method, and then evaporate at the rotovap. So you have this one, which is crude neutral compound. So you can purify, or you can just check the melting and boiling, so as instructed. So voila, if you have it, go back and discard the aqueous layer that we don't need it. Okay, now so we go back to the original aqueous from the first step. So let's say this one, you have the salt of the base and water. It's in the aqueous layer. So what do? You cool it with a bit of ice bath and then basify, adding sodium hydroxide concentrated. And then check the litmus whether it's turning red to blue. So then it's basic. So that means you really took all the base into your organic fraction. So this has to be done again 3 times of 15 milliliter, let's say DCM or ether. Okay, now so we can say aqueous layer again, you're going to keep it until we know for sure. And the other organic layer, you have the base now with the traces of water. Add the drying agent, sodium sulfate, do the gravity filtration, and then evaporate at the rotovap. So voila, you get B crude, and perhaps you can purify or just check the melting points and boiling points. And then if you are sure, check the data sheet and then go back and discard the aqueous layer properly into the right container for organic contaminated water layers, right? So those are the 2 charts, and there will be 2 other charts for some questions that I got. And so any questions, please post the questions. I'll answer. Good luck. So that's how you want to go to the exam. So 2 sheets, one is method is explained, the other one blank, so you can write as you go. Thank you.